Now let's look at the next three examples. This next example in your paper says what? A 14-foot ladder rests against a vertical wall. Let theta be the angle between the ladder and the ground, and let x be the distance the ladder goes up the wall. Alright, let me say I have some wall here. Here's, I don't know, my brick wall or whatever, okay? And then they talk about a ladder leans up against the wall. So here's my ladder right there. And it talks about that's a 14-foot ladder. Rest against a vertical wall. Let theta be the angle between the ladder and the ground. So this angle right here between my ladder and the ground is going to be theta. Then it says let x be the distance the ladder goes up the wall. So from right here to right here will be x. Alright, then it goes on to say if the bottom of the ladder is pushed toward the wall, how fast does x change with respect to theta when theta is equal to 45 degrees? Express your answer feet per degree to 2 decimal places. Alright, so what's going on? If we push the bottom of the ladder towards the wall, and wants to know how fast is x changing with respect to theta. Alright, let's talk about some stuff. dy over dt means derivative of y with respect to t. But it could also be an interpretation. This could also mean the change in y with respect to t. So let's suppose I had this dx over d theta. That could be thought of as a change in x with respect to theta. Now look at what it says here. It wants to know how fast does x change with respect to theta. How fast does x change with respect to theta? So they want to know dx over d theta. That's going to be my unknown here. Change in x with respect to theta. They ask how fast does x change with respect to theta whenever theta is equal to 45 degrees. So let's find this. So up till now, I always had an equation to take the derivative of, and it wasn't a problem. I don't have an equation now, so I need to come up with one. Look at your picture here. What's an equation we can come up with where we have x and theta in it? How about the sine of theta? Isn't the sine of theta equal to x over 14? Sine of theta is equal to x over 14, right? Now I have an equation with x and with theta in it, okay? I want dx over d theta, so let me solve for x here. So I'll say 14 sine of theta is equal to x, or I could say what? X is equal to 14 times the sine of theta. Now let's find the derivative of x with respect to theta. So theta is my variable here. I'm going to take the derivative with respect to. So we have 14 times, what's the derivative of sine? That's the cosine, right? All right, now what do they want to know? They want this, but whenever theta is 45 degrees. So dx over d theta, whenever theta is equal to 45 degrees, is equal to 14 times the cosine of 45 degrees, right? So that's 14. What's the cosine at 45 degrees if we think about our unit circle? Yeah, square root of 2 over 2, right? So that would be what? 7 square roots of 2? Now let's think about the units here, okay? Anytime in calculus we're dealing with taking derivatives and so forth, in this class we're going to say we're automatically assumed to be in radians, not degrees. Automatically going to be in radians. So what I just found was dx over d theta, change in x with respect to theta. So it's going to be units of x over units of theta. What are my units of x here? X is measured in what? Feet. And what is theta measured in, unless we're told otherwise? radians. So I have my change in x with respect to theta in feet per radian. So that's like 7 square roots of 2 feet per 1 radians, what I have right now. What did your problem tell you to do though? It told you to what? Express your answer in feet per degree. So I got the feet, I just need degree at the bottom. So I'm going to multiply by pi radians over 180 degrees. Guess we could do that, really unitless anyway. Alright, so what do I have? I have 7 square roots of 2 times pi feet over 180 what? Degrees, right? So go ahead and put 7 square roots of 2 times pi over 180 in your calculator. And think about what your unit is going to be. Feet per what? Feet per degree. I want to say this one's like 0.17 if we were up. Yeah. Put it in your calculator, get 0.17 feet per degree. What is that? That's how fast x is changing with respect to theta at the instant when theta is opened up to 45 degrees. Ooh, that was a lot of that one, huh? Let's look at our next example. Our next example on our notes. It reads, find all values in the interval from negative 2 pi to 2 pi. Oh, wonderful. A trig function. Yeah, that's this whole section. Find all values in the interval from negative 2 pi to 2 pi at which the graph of f has a horizontal tangent line. Horizontal tangent line. Remember, a horizontal line has a slope of 0, right? So we want to find what? The slopes of the tangent line and find where they are equal to 0. How do we find the slopes of the tangent line? We find the derivative, right? So the function they gave us is this, 4x plus 4 cosine of x. So let's find the slopes of the tangent line or the derivative. So f prime of x is going to be 4 plus 4 times, what's the derivative of cosine? Negative sine, right? So that means that f prime of x is equal to 4 minus 4 sine of x if I clean that up. Now what do I want to know? Where these slopes of my tangent line are horizontal or where they're equal to 0. So take your derivative there, set it equal to 0 and solve. Let's see. I can say negative 4 sine of x is equal to negative 4 sine of x is equal to what, 1? Where's my sine of x equal to 1? Well, sure, I'm glad I memorized my unit circle, right? Because when I memorized my unit circle, I had to point what, 0, 1 right here? And that was cosine sine. How about this point? That was 0, negative 1, right? So where on my unit circle did I have angles that whenever I took the sine of them, I got 1? That would be an angle right here at what? I have a sine that's 1 and an angle of pi over 2. Anywhere else? Well, if I go around 2 more pi, so 2.5 pi radians. But this tells me to do not go past what? 2 pi radians. How about if I started here and I went backwards like this? If I went backwards like that, wouldn't I have a sine that's 1 there? Make this true? Where is that? Negative what? 3 pi over 2 radians. Negative 3 pi over 2 radians. That's where I have horizontal tangent lines in that interval. Let's look at the last example from this section. Last example. It reads something like, find the equation of the tangent line to the graph of sine of x to the graph of the sine of x at x is equal to pi over 4. Find the equation of the tangent line. Well, every time we found the equation of the tangent line in the past, what do? We started out with y minus y subscript of 0 is equal to m tan times x minus x subscript of 0, right? What was x subscript of 0? That was the point they gave you, right? So x subscript of 0, f of x subscript of 0. We know x subscript of 0 is that particular x value they give you, right? Pi over 4. What's f at x subscript of 0? That would just be subbing in pi over 4 into here and calculating. What's the sine of pi over 4? Again, boy, I'm glad I memorized that unit circle, right? So right now, here's what I have. I have y minus square root of 2 over 2. I guess I could go ahead and put this. It's equal to m tan times x minus x subscript of 0, which is pi over 4, right? Now, what do I need? I just need what? M tan to fill in. So how do I find m tan? Take the derivative of y is equal to the sine of x. What do you want to call it? We could call it y prime. We could call it f prime. We could call it dy over dx. Probably y prime or dy over dx would work best. Well, what's the derivative of sine? Cosine? So m tan is really y prime evaluated at that x value, pi over 4, right? What is y prime evaluated at pi over 4? Just take this, evaluate at pi over 4. So the cosine of pi over 4. What's the cosine of pi over 4? Square root of 2 over 2. So I'm going to put square root of 2 over 2 for m tan. Now let's clean this up. So y minus square root of 2 over 2 is equal to square root of 2 over 2 times x minus square root of 2 times pi over 8, right? Now let's go ahead and subtract that for both sides. So we have y is equal to square root of 2 over 2x minus square root of 2 pi over 8 plus the square root of 2 over 2, and I'm guessing Wiley will take it like this. There we go. The equation of the tangent line. Just working with trig values. So what do you need to do? You need to memorize your derivatives of trig functions.